Bismillahirrahmanirrahim. In this video we are going to use a symmetry method to linearize nonlinear ODEs and find their analytical and general solution. So take a nonlinear ODE, say y double dash equal to sine y dash cube is nonlinear and usual method will fail to answer to solve it. Now we use power of symmetry to find solution of equation 1. Let's say this is my equation. You see this equation, admit a symmetry generator. This all symmetry experts know that this symmetry, this equation admit this symmetry partial by partial x. This the given differential equation is invariant, and when I operate this operator, like you can easily show that. Let me name it. This is my h. So when I operate this x on h, it will give me 0, and you clearly see that partial by partial x of y double dash minus sine y dash cube is 0. Okay, now we will use this symmetry generator and solve this. First we will linearize it and then we will solve it. So what is the procedure? We need to find coordinate T and S such that these two equations satisfy. So in fact we searching coordinates, so we are going from xy coordinate to T and S coordinates such that these two conditions satisfy. So you see partial by partial x t equal to 0. What that mean? T be y, and partial by partial x s is 1. What that mean? That s is in fact x. So my t is y and s is x. Now I want to write the given differential equation. We want to write y double dash equal to sine y dash cube in terms of t and s using this transformation. So let's see. Okay, y dash, so what is y dash? Y dash is dy over dx. So dy and y, x and y both are function of t and s. And for time being I am taking s to be dependent and t I'm taking s to be dependent on t. So x, what is dy? So I'm doing it separately. Dy is partial y by partial t dt, partial y by partial s ds. Similarly, dx is partial x partial t dt, partial x partial s ds. So putting value in them, what is partial y by partial t? So I'm writing that t is y and s is x. So using these, partial y partial t is 1 and partial y partial s is 0. Partial x over partial t is 0 and partial x over partial s is 1. So you see it is a partial y partial t dt and partial y partial s ds, partial x partial t dt and partial uh, x over partial s ds, and I can write it partial y partial t plus partial y partial s y x s dash, where s dash is ds by dt, partial x partial t plus partial x partial s s dash. Now I know that this, the value of it is 1, the value of this is 0, and the value of it is 0, and the value of this is 1. So I get 1 over s dash. This is the value of y dash. Okay, now I need y double dash. So y double dash is in fact dy dash over dx, and you know this will be partial y dash by partial t, partial y dash by partial s s dash, and partial, following the previous slide, partial y dash by partial s dash s double dash. Similarly, partial x partial t and partial x partial s s dash. Now I know this value and this value, but I will calculate these three values from y dash. Y dash is 1 over s dash. So y partial y dash by partial t is 0, partial y dash by partial is 0, and partial y dash by partial is dash is a minus 1 over s dash square. Now I will put these values in this equation. You see this is 0 0, and I get here something which is 1 minus 1 over s dash square s double dash, and this value is 0, this is 1, so I get s dash. So overall I get y double dash is minus s double dash over s dash cube. Now I will put y dash. Y dash is um, 1 over s dash. Y double dash and y dash in equation in the given equation 1. What is equation 1? And also I will put x as s and t is, so I will put these value in the differential equation. What is the differential equation? The differential equation is y double dash equal to sine y dash cube. So the value of y double dash is see, y double dash is this value. So I will put minus is double dash over is dash cube, that is y double dash. Sine y is t, you see here y is t, and y dash is 1 over s dash. This will become 1 over s dash cube because y dash is 1 over s dash. So you see this will cancel, and what I get? I get a simple differential equation. Sine is double dash is equal to minus sine t. You see this is linear in S, and much simpler equation. What is the solution? Solution is you see ds dash over dt is equal to minus sine t. So when we integrate it, we will get s dash equal to, integrate this with respect to t, so we will get sine when I integrate sine t, I will get minus cos, so I get cos t plus some constant of integration. Now you see what is s dash. S dash is ds by dt, and that will give me cos t plus c. Now integrate again, I get s. S is equal to integrate cos t, so that is sine t plus ct and plus another constant c1. So the solution in the new coordinate is s is equal to sine t plus ct and plus c1. This is solution in the new coordinate s and t. But what is the transformation? The transformation is x is equal to s and y is equal to t. So replace s by x and t by y. So my solution is in fact x is equal to sine y plus cy plus c1. So this is the solution of the original y double dash is equal to sine y dash cube solution, and you can verify it. This is homework. Verify that this is solution of this differential equation. This is one example. Let's take another one. Let's take y double dash equal to x minus y and y dash cube. This one, this admit the symmetry generator, partial by partial x plus partial by partial y. Yeah, this admit this symmetry. You can check it. This differential equation admit this symmetry. Now I need t0 and s1 is the as in the previous um, previous case. Let's call it example 2. Now you see, when I operate partial by partial x and partial by partial y on t, I get tx plus ty equal to 0. So when I solve it by characteristic method, dx over 1, dy over 1 and dt over 0. So this give me that t is in fact, solve these two. This is x is equal to y plus some constant. So that constant is t. So that means t is x minus y. This is my t. And what is s? You see, if I find s from this equation, this will be st plus sx plus sy equal to 1. Oh yeah, so that means dx over 1, dy over 1, ds over 1. So I am interested in this. Solve this. You can do the other one also, but that give me x is equal to s. So I find s and t, and now I want to convert this differential equation in the t and s coordinates. Just I do in the previous example, so I'm going quickly here. Take y is equal to s and x minus y is equal to t, and take t to be dependent on s. So if I put ys, so I get this. So y dash is y is ytt dash, x is xtt dash. So ys is 1, yt is 0, ys x is 1, x is 1 plus t is 1, so t dash, that is y dash 1 over 1 plus t dash. Okay, now y dash t is 0, y dash is 0, and y dash t dash is minus 1 over 1 plus t dash square. So now I need double dash. Y double dash is y s y dash. Y dash is y dash tt dash y dash t dash t double dash, and x is t dash t dash. So this is 0, this is 0. You see from the previous slide, y dash t is 0, y dash s is 0, and y dash t dash is this value. So I get minus 1 over 1 plus t dash square t double dash, and the denominator 1 plus t dash. So y double dash is equal to minus t double dash 1 plus t dash cube. So this is a y double dash. So I'm writing y double dash. Y dash is 1 over 1 plus t dash, and y is s, and t is x minus y. So these are the variable I will put in the differential equation. So I'm writing the differential equation also over here. Y double dash is equal to x minus y and y dash cube. So I have to put all these things in this differential equation. So what is y double dash? Y double dash is minus t double dash 1 plus t dash whole cube. That is y double dash. And x minus y is t. X minus y is t, yes. This is t. And then y dash. So what is y dash? Y dash is 1 over 1 plus t dash, and this is whole cube. So minus t double dash 1 plus t dash cube, and t over 1 plus t dash cube. So what I get? I get a linear differential equation. T double dash plus t equal to 0, which is very simple differential equation and linear, and that is our goal. So what is the solution of this differential equation? Solution is t is equal to c1 cos s plus c2 sin s, and y is equal to s, and x minus y is equal to t. So replacing this, t is x minus y, c1 cos y plus c2 sin y is solution of y double dash equal to x minus y, y dash cube. So this is the analytic solution of this differential equation, and that is the power of symmetry. So we solve two non-linear differential equation. They are in fact not non-linear, but they are written in bad coordinates. If we change the coordinate according to this transformation, then it will become a linear, simple linear differential equation, and we will solve it and transform again into original uh, coordinates. Okay, thank you.